Hello, everyone. Yes, everyone is in the room. So hello, everyone. My name is Roman Zufik, and I will be your moderator for today's session. I think we can start. We are not going to wait for more people. They will arrive on the way. So let's start with today's agenda. So today we're going to present you the outcome of the Marine Data Challenge that were a journey of a few months. So we will have Vasilis and Fabrice presenting the feedback from both end users and downstream users meetings. I will explain to you that a bit more afterwards. And then we will provide you with kind of a practical kit with everything you need to know to start building a data solution to existing marine challenges. So we will have first Tina that will present you the use case as illustration and inspiration of real solution in the markets. Then we will have Valentina presenting the products to use in such cases. And then Fabrice will give you a demo to present some tools of our websites. We will have then a Q&A session and a conclusion. But you have to know that you can ask a question at any time using the question mark at the bottom of your screen, or also the chat. You are free to send us message on the chat and we will have a look at that too. So just let's go back to the Marine Data Challenge and what it was. The Marine Data Challenge was an innovative format that we had at the Copernicus Marine Service that allowed us to create dialogue between the three parties, end users, downstream users, and the Copernicus Marine Service. And this event has been conducted in partnership with the MITEF Greece. So on October 11, we held two separate meetings with Greek end users on the one side and downstream users on the other side. It was small open mic meetings that allowed discussion with these users. And it was the opportunity for them to present their activity, the challenge they face, the needs that they have, and for us to present our service. So the real objective was really to bridge the gap between the end user needs and the downstream users' capabilities on marine sustainable projects. And it was really aimed to foster cooperation. And we really focused that on 4 blue markets, which are trade and marine navigation on one side, marine food on the other one, coastal services and tourism, and natural resource and energy. So these are the blue markets that we will focus again on today. And we will start straight away now with the main outcomes of the Marine Data Challenge and on these 2 events I talked about. So I will give the floor now to Vasilis and then Fabrice to present you these outcomes. So please, Vasilis, the floor is yours.
Good morning, everybody. Thank you for joining us this morning. I'm going to spend the next few minutes to share some feedback we got from end users, from people that they would like to see applications supported by the data the Copernicus Marine Services can provide in order to solve significant problems in their businesses. So let's start with the coastal services. This is an example. There are similar things. So in each case, I will present one example, but there are other things that you can extrapolate from that. So a lot of operations here in Greece, they have a coastal operation like a windsurfing club or a diving club or whatever, and they have a very short period of time to operate that during mostly the summer season. These operations rely very much on specific weather conditions. For instance, a windsurfing club can operate only when there is wind. And if you run a very lean operation, you want to make sure 2 things. First of all, your operation is run in a safe way, and you minimize the losses, either because you spend resources when are not needed, or because you do not get the revenue when you could have. And although in most cases people have the the local weather forecast. These weather forecasts are very dynamic, and they are very localized in many cases. So we had discussed with people running this type of operations, and they would like to do two things: maximize the available time of operation, which may be throughout the day or throughout the week or throughout the month or even throughout the season. And for that reason, they want to have a very localized weather forecast almost in real time. I have this problem myself. Sometimes I see the forecast for 2 days later on a weekend. The wind is supposed to be strong. I prepare my gear to go windsurfing, but as I arrive 2 weeks ago at the club, I put everything together only to find out that there was no wind. So we need to have very localized and almost real-time weather data. And because sometimes this means that you have to do changes on your schedule at the very last minute. You need also alerts and ways to disseminate the changes. Either these changes relate to the people that work there or the customers that they plan to visit these locations. And of course, you want also to, if you can have a longer time forecast at this icon, you can also automate things like a reschedule. Some people go to these operations to have classes. You want to reschedule the classes according to the weather conditions. So this is a very particular example that relates to water sports, but think of other coastal related services. They would need these type of applications to solve their problems. The next group is the trading and marine navigation. We have all these huge ships you can see in the picture going through the oceans, and at some points they stop for quite some time in ports to load and unload. During these times, marine growth comes out on the hull of the ship, and that relates to several things. And eventually that marine growth creates hydrodynamic problems that increase the operating cost. They increase the consumption of fuel, and in particular this period when the fuels are very expensive, that creates serious problems. So the need for ship operators and ship owners is to do two things. First of all, to understand when the hull fouling goes to a point that there needs to be a cleaning process, and this is, trust me, it's not a very simple process. It requires a lot of resources to be sometimes moved around the world. It takes time, and that affects the schedule of the ship. So they need to optimize the scheduling and also be able to do that at the proper time without affecting either the operation time of the ship or the performance of the ship. So they need to have local ocean bioenvironment consistency data to understand how the marine growth is going to stay to materialize under the hull of the ship for a given stay in the port. They want to simulate bioenvironmental behavior for predefined hull shapes and specific hull characteristics. Not all shapes, not all ships grow in the same port, in the same conditions, marine growth in the same way. To alert for critical accumulation based on predefined criteria, because as I said, this affects the performance of the ships and has ripple effects, financial effects, which are significant sometimes. And to get this data out in specific formats that can be used in other modeling systems. One of the very common system is what they call digital twins or other software that does ship optimization performance. Sometimes that relates to operators, to insurance companies, and others. So we need to get the data out. Again, this is an example, but this is a huge problem for the shipping industry. The third area was the natural resources and energy related to coastal locations. We had talked with people from islands where they have very sometimes inefficient or sometimes old local microgrids, and they are loading with the renewable resources, and these renewable resources just sometimes waste energy because they try to get the energy through the system cannot support that, and it is a waste of money and of course resources. So they need to have local weather data specifically for the locations where these renewable sources are, so they can have a greater visibility on the production profile. And then they want also to have a forecast for other weather conditions, because for instance, during the summer you have higher heat with high wind, and then you may expect that the utilization of air conditions go high. So, or you have humidity if south blown winds are coming, and you want to manage all these parameters in order to optimize the operation of the network. And then, of course, you need the data to come out in multiple formats to be entered in the system of the energy network operators, and alert based on custom set criteria. For instance, you may have adverse conditions wind-wise that would need to the operators to protect their equipment by shutting them down, or changing the pitch of the blades and things like that. The fourth area was marine food. We look into aquaculture in particular, which is a growing business here and in other places. The problem there is that, again, they have the fish into these nets, and they want to do two things. First of all, to find the best locations, and then to maximize the quality of the product while minimizing the use of resources, especially for the first part, finding the best location. We realize that what we think like a vast space in front of us in the picture, which doesn't change that much. Maybe you have microcurrents or currents coming out of under earth rivers affecting the specific location. So they need to have very clear data related to bioenvironmental conditions, and they want to also have alerts about changes given specific criteria. Some of them they use sensors, but they need extra help in order to forecast potential changes correlated with environmental conditions. They want to get them out. Many of them, they have new systems that they use for automated feeding or protecting, shutting down specific parts of the operation to avoid adverse weather conditions. So they need to have localized daily weather forecast, and be able to compare particular parts of the data, because sometimes they have to move the nets from one place to the other. That shift may be 100 or 50 or 100 meters, and they want to be able to optimize that, because parts of the locations of the sea that the nets are placed may be depleted by specific resources, and they want to move them to somewhere else. So these are four very specific examples that the data from Copernicus Marine Services can be very useful. And I think there's great opportunity for developers or entrepreneurs to come up with solutions to address them. Some of these problems may sound very small, or some others may sound that they have been or can be covered without solutions. But trust me, the discussions we had with the people here showed that either they are not served at all or they are underserved. So there's plenty of opportunity. Thank you.
Thank you very much, Vasily, for presenting us these 4 challenges that actually are existing in Greece right now and that need a solution to develop. Now we're gonna go to the downstream user meetup feedback that Fabrice will present right now. So please, Fabrice, the floor is yours.
Thank you, Roman. So let me change my slide. Okay. So it was very interesting to have this feedback from the end users because it helped us to identify the challenges that the end user are facing, and we know that at this point some problem identified by the end users are related to marine products and others are not. So during the downstream user meetup, we organized the same day than the end user workshop. We try to share with the downstream users the problem that they can have and how we can support them in the use of marine products. And the goal was to introduce the current status of the service and the future improvements to keep the contact with our community of users. So the meetup focused on the 4 blue markets, and it allows us to engage open discussions with a small group of downstream users identified during the first event of the series. So we present the potential the potential of using Copernicus Marine Service products. We explain our user-driven approach of the service and the importance to collect the feedback to improve the catalog of products and the rest of the offer of the service, and to collect the needs in terms of data access, product and variables and support. So the feedback, the audience was composed of mostly by regular users. No particular needs on training because they know how to use the data, but more on the improvement of the catalog and the data access. So on aquaculture and fisheries and coastal management, they need high-resolution products for coastal activities, availability for real-time data about the sea surface pollution, like pollution alert by mobile phone. And on marine navigation and renewable energies, high resolution for wave height, wind speed direction products, tools to manipulate data formats to change between the formats of the different files, and access to additional products related to marine navigation, for example, IS position, main routes, main shipping routes. Just a quick few words about the service evolution of the Copernicus Marine Service. We try to engage all the users to give us their feedback and their needs in the future in order to feed our service evolution process and to review what we can do in the future in terms of data access services and user support. So it's very important for us to keep this dialogue open with downstream users, and it's very interesting for us to have also the position, the voice of the end users to feed again this service evolution.
Thank you very much, Fabrice, for presenting us this downstream user meetup and the outcomes and the discussion that came out of it. So now it's the beginning of explaining more about the Copernicus Marine Service and how we can address the challenge that Vasily presented. So now I welcome Tina. Tina, the floor is yours to present some use cases using Copernicus Marine Service data.
Thank you, Roman. So we already had in a previous workshops, we already saw like a lot of different Copernicus Marine Service use cases. use cases are basically the downstream applications or developed services by using Copernicus marine data. Today, we are going to have a bit different show. We are going to show you how actually the project leaders of such applications are showing their final product. So to start with, we are going to present aquaculture and fisheries, and within this particular market, one really interesting use case is Umitron. So Umitron Pulse is a web-based service for monitoring ocean environmental data, and one of the things that they do is that they provide farmers, fish farmers, an easy way to regularly monitor changing water conditions. So now we are going to see their video, their promotion video.
In this video today, I'd like to quickly introduce you to Pulse, a new service from Umitron that provides ocean satellite data in an easy-to-use, user-friendly format. So right now we're currently looking at the Mediterranean Sea. We're looking at sea surface temperature. You can see over here, pretty warm by Tunisia, about 29 degrees. A little cooler over here between Turkey and Greece at 22 degrees Celsius. So you notice when I hover over a point, I can actually see what that exact temperature is. Also can check the scale over here. So I'm going to zoom in. We have a pretty tight mesh, pretty high resolution data here. And you'll see it automatically adjust as I get closer. Also, I can refresh here to adjust the legend based on the new data that we're looking at. So in addition to looking at data on the surface, I can also look at it 5 meters deep. You see it's a little bit cooler, as well as 10 meters deep, which is again a little bit even cooler. Also with this bottom slider, I can look at data from yesterday, since I was currently looking at data from today, and I can also look at data 1 day and even 2 days into the future. In addition to temperature, we also have dissolved oxygen, chlorophyll, salinity, and wave height. Quickly here, we can check chlorophyll and see how things have changed. And if there's a really specific point that I'm interested in, I can click on it and we'll pull up some charts here, and we can see how surface temperature is changing every day between night and day. Temperature in general has been trending upwards the last few days and looks like it's going to continue into the future. Dissolved oxygen's been trending down, chlorophyll's fluctuating, salinity fluctuating, wave height's been fluctuating. Those are the basic features of Pulse. If you think you'd be interested, you can sign up for your own free account today at pulse.umitron.com.
So you saw one of the interesting applications, how the different type of the data can be used in a particular application, and how it could be useful even maybe for some of you. The second market that I'm going to show, it's use cases within coastal management. So here we have one app that it's called I Clean My Sea, that was developed to allow users around the world to detect floating marine debris by simply taking a picture of the floating trash, and then through the app the end users could find something more about it. Vincent, could you please play the video? So you can see with the I Clean My Sea app how with the raising problem of the plastics, this could help to for the solvers to find the plastics and remove it from the environment. A similar problem was solved in a bit different way by the modeling plastic pollution, meaning you can also model where the plastic particles are going to go. So in this animation that you're going to just see, you're going to see how the plastic distribution goes and how it's basically connected to different cities. Basically, the biggest city, you can see that there is a growing part of the there is a much huger part of the plastics that it's happening around bigger cities than obviously on the small cities. So this is the example of the obviously Mediterranean Sea. And here on the upper image, you can see which big cities are involved, and obviously you can see that the River Po is doing a lot of problems, and the other big cities, that particularly the ones that have a lot of shipping lines. The next use case, as an example, is Guta Vizir, which is a decision support system for ferries in Adriatic Sea. One of the ideas that they had is to have less CO2. Basically, the CO2 ferry optimized ferry routes, obviously depending on meteo and marine conditions. So now I'm going to see in the video how they use the data to plan shipping routes.
Maritime transport, being responsible of about 3% of global greenhouse gas emissions, significantly contributes to climate change and its detrimental consequences for the functionings of the ecosystems, the human well-being, and the stability of societies. Conversely, the demand for transport service is on the rise, and not all regions are well connected. For instance, in the southern Adriatic, the mobility of freights and passengers is hampered by a low number of cross-border maritime links. As long as Italy and Croatia are concerned, just the Bari-Dubrovnik route exists in the southern part of the basin. Is it possible to improve and enhance maritime transport and, at the same time, contribute to reduce emissions in the field of mobility? Guta project aims at reducing the carbon footprint of ferry routes between Italy and Croatia by means of meteo-oceanographic forecasts and automated route optimization tools. The project realized an operational web tool called Guta Vizir, devised for computing least CO2 ferry routes, depending on forecast meteo-oceanographic conditions in the Adriatic Sea. The tool is based on three main components: the environmental forecasts of waves and sea surface currents provided by the Copernicus Marine Service, the Vizir ship routing model, and a web application for browsing its results. The Vizir model can compute routes of minimum CO2 emissions. Operational runs of Vizir are performed at the CMCC Supercomputing Center in Lecce, Italy. Every day, the Guta Vizir web service makes available more than 7,000 fresh routes, freely available and downloadable from the web. The seakeeping and CO2 emissions of a ferry were estimated through data collected from a ship simulator installed at the University of Zadar, a partner of the Guta project. The CO2 and carbon intensity indicator savings obtained through Vizir are computed for routes between various ports, departure times, and ships' engine loads. A user-friendly interface enables users browsing least CO2 routes and can support the decision-making process before and during navigation. Indeed, The Guta project has a clear vision. Ship route optimization should be an easy-to-access service for the benefit of both navigation and climate.
So this was Guta Vizir application, and now we are going to see ICC. ICC is an application developed by Drift Plus Noise and the Meteorological Institute of Norway, and they aim to be a one-stop shop for ice information, addressing the every activity that is happening in the waters that have ice, because ice obviously can impose a problem, particularly when it goes into shipping, and how the route shipping could change depending on the where the ice is in the water. So let's see ICC application.
To navigate changeable, icy waters, you constantly need to know, what is my safest and most fuel-efficient route? That's not easy when ice information is spread across the internet and you have a poor internet connection. So what if you could display sea ice on a map in near real time as simply as this? With ICC, all the actionable information you need is provided in a single map-based display. So you can take the safest, most direct route to save costs and time to avoid ice entirely, or to find the best route through the ice with an ice-breaking vessel. Here's how easy it is with ICC. Its map-based interface quickly shows you a variety of high-resolution sea ice information, regularly updated and with 24/7 reliability. Click on the map to get up-to-date satellite imagery, or zoom in to high-resolution images for more detail, even with a low-bandwidth connection. ICC is the one-stop solution for ice information on board. Take a free trial and find the clearest way ahead.
So that was ICC application, and now we're going to show a use case in terms of a renewable energy sector. There you can see Wave Piston, which it's one of the applications that developed a quick assessment of the feasibility of wave sites, and the data of Copernicus Marine service wave data allowed Wave Piston to conduct potential power generation simulations on given project sites. So let's see their video.
For a large number of islands around the world, securing the supply of electricity and fresh water comes at a high price. Today, they are largely dependent on expensive fossil fuels that pollute their pristine nature. But wave energy can change all that. Ocean waves hold the power and the promise to produce electricity and clean, fresh water. Thanks to a new and patented breakthrough technology made by Danish engineers at Wave Piston, it is now possible to extract the energy from the ocean waves and transform it into electricity and clean, fresh water.
The total wave energy potential is huge. We estimate that wave energy can cover as much as 50% of today's global electricity consumption.
The evidence shown by the OES Environmental State of the Science report indicates that there are no negative effects or negative risks to the flora and fauna when installing ocean energy devices.
Wave energy and Wave Piston is a perfect companion to wind and solar, complementing these other renewable sources. Placed in the ocean, the construction is almost invisible, Our technology combines both the production of electricity and the desalination of seawater into clean drinking water in one and the same technology from the energy in the waves.
What is new is, if you have a number of plates, some of them being pushed, some of them being pulled by the waves, if you connect them, they will start to cancel out each other's forces by pushing and pulling. And this is the basic principle of the wave piston system, and on which we have a patent, which we call force cancellation. When the waves pass, the plates are moved, they drive pumps that suck in seawater and push it to shore through a pipe. And on shore or on a spar, you can have a turbine or a desalination system, which creates energy or drinkable water.
What I like most about wave piston technology is its clever engineering. The system has made effective use of physics and hydrodynamics of the ocean environment. As a result, the system is extremely light and easy to install. Basically, you can put all your mooring material in a container and move it anywhere in the world that you like. And you can install the mooring system by using local means.
The system has many advantages. The design is inspired by the flat pack principle. It consists of many identical units that ensures high automation. All pre-assembled components fit into standard transport for easy logistics all over the world. And the module system is also a low-tech system for high local involvement in final assembly, operations and maintenance.
The core team has all the technical and management skills required to become a successful technology company. This core team has been the same since the very beginning, and they continue with focus and enthusiasm to pursue our mission to make wave power competitive.
We've been through several development and test rounds. Latest in the North Sea, we have experienced up to 12-meter waves. We've won several Danish and European grants to support our development, and we are currently installing our full-scale demonstration system in Gran Canaria. For this installation, we have won the EU Horizon 2020 grants, SME Phase 2, and Fast Track to Innovation.
The funds from this equity issue will be used for the 2 EU-supported projects to demonstrate the system in full scale and to prepare the first commercial projects. First step is to focus on islands, island resorts and isolated coastal communities. They are highly dependent on diesel generators for power supply, and most of these locations also lack fresh water. We can deliver a competitive solution, cut the average price almost in half, and remove the large dependencies to fossil fuels that are transported over large distances. Replacing the diesel generators and delivering desalination systems based on wave energy is a 28 billion euro market that is waiting to be exploited. We have already several interested customers ranging from islands in the Atlantic Ocean, in the Caribbean, in the Pacific Ocean, and hotel resorts in the Indian Ocean. We can make a large positive impact locally in these societies, ensuring more renewable energy and more fresh water at a lower price, respecting the local unique environment.
Wave Piston is making wave energy affordable for the many and thereby securing a greener and better world.
So this was wave piston, and these were basically the use cases that I wanted to show you again and today, and I hope that you got some idea how not only which data can be used that we show recently, but also how the application, when it's developed, how the project leaders are promoting their services, and to get a bit broader picture about downstream services. And now I'm going to let the floor to Valentina Giunta. She's going to present Copernicus Marine Service products.
Okay, 1 second, let me share my screen. Hopefully all of you can see my screen. So what I'm going to do today is just I'm going to present some of the products that we have in our catalog in Copernicus Marine Service. So before that, so I would like to say that we have many variables available in the catalog, and the way that we divided these variables are using what we call blue, green, and white ocean. So basically, when we talk about blue ocean, we talk about the physical state of the oceans and all the variables that are involved in this area, such as temperature and salinity, currents, waves, sea surface elevation, wind, and many others. So when we talk about green ocean, we talk about the physical state of the ocean and all the biophysical processes are happening in the ocean that are affecting the life and many other chemical processes too, such as, for example, nekton and plankton, organic carbons. We offer data from many nutrients, oxygen, carbonized system, and optics. And then we have what we call white ocean. Basically, they're all the variables involved on the sea ice, such as in the Arctic, on the Antarctic, such as sea ice concentrations and thickness, sea ice extents, sea ice velocity, snow, ice surface temperature, and many, many other variables. So just to give you an insight of what we offer, we have three types of data sources, such as model data, in situ data, and satellite data. And the temporal coverage that these source of data have are multi-year, what we call multi-year, which is we offer data for around 27 years in extension. Then we offer near real-time data that it can be instantaneous, 15 minutes, hourly, daily data, and then forecast up to 10 days. And the geographical coverage that those products have are, well, global, and then we have all the European seas, such as Baltic, Mediterranean Sea, Black Sea, and many others. And also we offer data in the Arctic and in the Antarctic too. So not only we offer satellite model and in situ data, we also offer what we call ocean monitoring indicators, which are key variables for monitoring the oceanic trends in line with climate change. So these are free, downloadable data sets that they're covering the past 27 years. So the way that these indicators are built, they are actually constructed and built using the Copernicus Marine Service products. And you can find them online. They have different kind of families, what we call families, such as climate variability, currents, ocean heat content, ocean health, sea level, sea state, and many others. So if you go to our main website. So you have a single access point for all these ocean products, for all these indicators that you can see here on the slide. So we offer nearly 300 products, so it's very hard for me to just to show them all of them. So what I'm going to do today is just I'm going to show the top products in our catalog, the ones that are most used by our users, so you can have an idea of what it is available online. So if we start with the aquaculture and fisheries markets, so what I'm going to show you here are two different kind of products. One is a model products, as you can see on the left side of the slide. So this is a global ocean biogeochemistry analysis and forecast model. And on that video, you can see some of the variables that these products can offer for you. So the period that you can find this data is from 2019 to present. It has a 4-degree resolution. It also offers forecasts up to 10 days and offers information about more than 10 variables, such as chlorophyll, phytoplankton, oxygen, nitrate, phosphate, many other nutrients, CO2, pH, primary production as well. Because this is a model, it uses satellite data as an assimilation. That means that it actually improves the quality of the product. And it has a temporal resolution of daily and monthly. And then on the right side, you can see the indicators, which is a global surface ocean pH trend. So as you know, the pH has a very important influence on on acidification on the ocean. And this is actually a big problem right now with climate change. So these indicators can help you to keep an eye on the pH and how it's changing through the years. And it's very important for aquaculture purposes. For coastal management, we have the Baltic Sea. In this case, I'm showing you the satellite product that it has suspended matter, turbidity, backscattering, chlorophyll, and the period for this product is from 2020 to present. So this product is based on Sentinel-2 satellite, which has a very high resolution on the coast. So it's perfect for coastal management purposes because you can have a very high resolution of what is happening in that area. And you also have daily and monthly data and different processing levels. And this is not only available for the Baltic Sea, you can find it available for the European seas and also for the Arctic. And on the right side, you can see another indicator for this specific market, which is mean sea level for the Baltic Sea. So you know that sea level rise is also very important in the context of climate change. So we also offer indicators for the different European seas, for the global ocean too, to see how the sea level rise is actually changing in the different areas. For marine navigation, I'm showing you two different products. So on the left side, you can see the Arctic Ocean Physics Analysis and Forecasts, which offers not only physical variables such as temperature, salinity, currents, and waves, but also offers you information about the sea ice. So you have sea ice thickness, you have sea ice area fraction, sea ice extent. And the period that this product offers is from 2019 to the present, and it has a spatial resolution of around 12 kilometers. Also offers forecasts up to 10 days, and it has a lot of information from other variables as well. And again, because it's a model, assimilates in situ data and satellite data to offer better results. And the temporal resolution that you can find here is hourly and daily. And then for the indicator in this case, I'm showing you the sea ice extents for the Northern Hemisphere. So sea ice extents and all the sea ice variables are very important in terms of navigation and shipping. And they're used in many of the use cases available on the Copernicus Marine website. So this indicator is actually it's being used a lot for a lot of users. And finally, for renewable energies, what I'm showing here, it's two products for the Mediterranean Sea, which are also available for other regions on other European seas. But this one is it's a sea wave analysis and forecast product, which offer information about the wave spectra and wave variables such as wave direction, sea surface wave height, and many other variables as well. And the period for this one is from 2019 to present. It has a spatial resolution of 0.042 degrees, which is a very nice resolution. And it has offered forecasts up to 10 days as well, and assimilates satellite data such as sea wave height to improve the results. And the temporal resolution for this product is hourly. For the indicator on the right side, you can see the significant wave height, the mean 99 percentile, and also the anomaly. This is very important to study extreme variability. So when for renewable businesses, sometimes they need to know how the wave field and the wave variables are changing. And so they use these indicators to start planning ahead. And this is all for me. So I hope you enjoy all the little products that I have to show you today.
Thank you very much, Valentina. Now we will move on to the web and tools demo by Fabrice. But before I give him the floor, I invite you again to post all the questions that we have, because this will be the final speaker that we will have before the Q&A. So your question will be answered very soon. Thank you. Fabrice, the floor is yours.
Thank you, Roman. So I will share my screen. Okay. So let's start this demo with the homepage of the Copernicus Marine Service. So as you can see on the homepage, you have access to a main button here. With Ocean Products, you will dive directly on the catalog of products. So you can see the different variables and the different products appear here. You can filter and choose the relevant products for your activity. And before to dive into the catalog of products, perhaps you will choose to have an overview of these products. So you have to choose Ocean Visualization here. When you arrive on this page, you will discover 3 different kinds of viewers. They are dedicated for different audience. The MyOcean Learn is dedicated for general public. You have access to key variables, and this is animation on the sphere. Then you have the MyOcean Lite, which is directly plugged to the catalog of products. So the products are updated daily or hourly. And the MyOcean Pro. And I will make the demo on the MyOcean Pro, which is our masterpiece of the visualization tool to dive into the product. And you have access to the catalog also, and you can directly download the products. So this is the MyOcean Pro. So as you can see, you have different kind of menu. Okay, so you can access to the layer menu here, and you can choose to add different layers. You have to choose the products and then the data set and then the variable to display the correct variable on the viewer. You can use filter, you can use the free text search. As you can see, you can filter by area of interest, temporal resolution, source of products. And here we are watching the seawater potential temperature from this product. You have access to the information of the product. So this is a global ocean physics analysis and forecast product. So it means that this is a numerical model product. So you have access to 3 dimensions. Because you have access to the information from the surface to the bottom of the ocean, thanks to the product. And you will see on the bottom of the screen, you have the timeline to navigate in the time and display the different date of the products. And you can see it's updated automatically. You can choose also to move into depth. So I will change the depth. Okay, this is a good one. Let me refresh my screen. Okay. So then when you want to display different layers, different products, you can dive into the catalog of products. So for example, let's try with SST anomaly, which is very important to show or to display the potential zone of marine heat waves. So I will enter the code of the product, and the code of the product is this one. So this is the Mediterranean Sea high resolution product. This is a satellite observation. So I click on Add to Map. And here I can find some information like the sea surface temperature anomaly. I will add this layer. And as you can see, I have the 2 layers, and I can play with the different layers. I can choose to hide the global one, and just to display the Mediterranean products. Here I can zoom in, zoom out on the region, and I can play with the layer. I can change the color map. I can play with the opacity if I want to keep the layer below, like this. Okay, it's very useful if you want to display some phenomena and correlation between two variables or much or more, sorry. And you can play also with the range of your color bar. Here, I can play with this. Okay. And again, I can change the date and navigate in the different available dates. Let's move now to another product related to coastal management. This is a high-resolution product on the coast. Valentina already presented this product on the Baltic Sea. Let's dive into the product on the Mediterranean Sea. So you can access to concentration of chlorophyll, for example, or suspended matter. Let's dive into the chlorophyll. So this is very a high-resolution coastal product. So as you can see, you have information just on the coast. I can choose to add a new product on the chlorophyll on the Mediterranean Sea. It is also satellite observation from the Olchi product. And this one covers all the Mediterranean Sea. So if you work on aquaculture, coastal management, if you want to make some measurement or a report on the water quality, it can be very useful to have this access to these products. And if you want to download the product, you have just to click here. So you have to be registered, obviously. The service is open and free. So you have just to register. It's very simple. And then you have just to select your area of interest. Okay. And you see the boundaries automatically fitted, and then the time range, and you can download the data directly. And you will have an ETDF file on your computer, and then you can use another different tool to play with the data. You have some features also to have direct access to the value of the products in a specific point. Like this, I can choose another point. I can be very precise with the information of longitude, latitude, and then I click, and you will see the evolution of the chlorophyll, for example, during the time. You can delete some graph. You can add other graphs, and you can play directly on the graph to access the data and access more information. Another tool I would like to introduce you is the data viewer of Wikio. It's the Wikio platform. So I will stop sharing my screen just to show you 2 slides of my presentation. Yes, the first slide. Oh, sorry. So to explain you the difference between the Copernicus Marine Service and Wikio platform, it depends the data you need. If you are looking for marine products, you can access directly all the products available on the Copernicus Marine Service. But if you need more information on the atmosphere, for example, the climate or the land provided by the different Copernicus services, you can directly access these products on the Wikio platform. So the main difference are here. So on the Copernicus Marine Service, you have marine products only. The two services are open and free. You have access on the Copernicus Marine Service to ocean monitoring indicators and ocean state reports. So it's very for a high level of expertise on the Copernicus Marine Service. You have a powerful viewer with a lot of features. You can access to e-learning material and a strong user support. On the Wikio, so the Wikio is a Copernicus DIAS platform for data information access service. You can access all the Copernicus products from the Copernicus services and the Sentinel constellation. This is open and free to download the data and to access the Jupyter Hub with some Jupyter notebooks available. But if you need more computational resources, they are available on Wikio, but you have to subscribe a pay plan to access virtual machine and CPUs. It can be very relevant if you start new activities and if you want to develop some codes and some program near the data without downloading a lot of information, because some files can be very huge. So again, I will share my screen to show you, to give you an overview of Wikio. So let's start with the home page. So this is the home page of the Wikio platform. You will find a lot of information about the service and what is available on this platform. So you have access to the data through the viewer. And as you can see, I just upload two kind of satellite observation from Sentinel-2 and Sentinel-1. This is the main difference with the Copernicus Marine Service. You have access to the Sentinel-2 and 1 data, for example, if you want to have information on the coast. It can be very relevant for your activity on coastal management to have access to this catalog of data. The viewer, there is less features than the Copernicus Marine Service viewer, but you can play with data. You can also filter the data and browse the different catalog of the Copernicus services. And again, you can add to map. Once you have displayed the data you want, you can also directly subset and download. You need to be registered. Again, it's open and free, so don't hesitate to have a look to this catalog of data. As you can see, it's similar to the Copernicus Marine Service viewer. You have to define your area of interest. You copy on the bounding box the definition, then you define the start and stop time, and then you request the data. You can access also the IPR requests. On Wikio, we have developed with our partners what we call the HDA API for harmonized data access, because the products are coming from different producers of data, from atmosphere, climate, land, and marine. We try to harmonize all the products and the variables and the files with the metadata and so on. And the idea with this IPR request is to have a simple way to access the product. So you have just to copy this IPR request and copy paste on your Python script to access directly the products on your code. So it's very simple. Don't hesitate to have a look on this. Just a quick look on the dashboard. Once you are registered, you can access this dashboard, and as you can see, you can directly have access to the Jupyter Hub. So this is my profile, and I can access the Jupyter Hub platform from Wikio. This is free. If you need virtual machine, you have to subscribe to a pay plan to choose the relevant plan for you regarding your need in terms of CPUs, storage, etc., etc. So I hope you enjoyed this overview of the different platforms, and I let the floor to Roman. Thank you.
Thank you, Fabrice, for the presentation. Do not turn off your camera because now it's time for Q&A, and I invite all the speakers to open their camera and mic also for when they will talk, and then we will move on to the question. So the first question we had was one from Sonia, who asked, the assessment of the renewable energy you are talking about uses only operational wave model, or does it include satellite altimetry data as well? I guess this was a question when Vasily was presenting. So Vasily, if you can answer.
Well, I cannot directly answer that because we try to understand from the end users what type of data they want, what type of problems they want. We cannot tell what type of data these problems require in order to be solved. So and I'm not very familiar with the data. So I think it can be used, but mostly we're talking about coastal energy, so the altimeters may not be that relevant.
Thank you. Anyone else want to add something to the answer, product-wise?
For me, it depends about the renewable energy you are talking about. If it's a tidal energy or other kind of energy, but all these products are available on the Copernicus Marine Service.
Next question was, what are the budgets that users have to pay for these services? I think it's.
It was again for during
well,
my
it depends
presentation.
on which services you're talking about, because this I think that this question arrived before Fabrice explained how Copernicus Marine and Wikio are functioning. So registration, all Copernicus services, including Copernicus Marine, the data is free and open to everyone. So there is also, okay, this adds to another question a bit, but there is no data that is delivered per certain application. Basically, you take the data and or different product, you download it and you use it in a way you would want to develop your application or your defined service. But also when it comes to Wikio, then the things are a bit more complex, because if you want to use their computational resources, then there are different plans. So if Fabrice wants to add something more about the Wikio, but I think you already mentioned everything during the presentation.
And I think this question came during the Vasily's presentation. No?
Yes.
So I think it's more about
the okay.
services. Yeah.
So, if I may add, we did not get specific budgets that the
I don't know if
end users
Vasily wants to add something or.
Yes, sir. He's talking.
Can you hear me?
Yes.
Yeah. So I was saying that it was not very clear the amounts the end users may be willing, but I guess this is part of the entrepreneurial aspect. You have to understand what value you're delivering to the end users, and then price your services accordingly. And given the fact that a lot of the data is for free, you have a huge margin if you price the things nicely, and try to figure out again what is the value you're delivering to them. So if right now they get zero value and you provide them, for instance, 10 euros a day or whatever, then you can claim a significant amount of that. So.
Thank you. Next question is from Maria. How could we improve the marine sector sustainability to achieve the SDG, which is a very broad question? Does anyone dare to give it a try?
It's complicated. Yeah, it's a very wide question, but our role at Mercator Ocean as implementer of the Copernicus service is to serve and to provide information to help the different governments to facing these challenges, and we are committed to serve the implementation of the directives as the SDGs. And this is the case, for example, with the SDG 14, life underwater. We have a lot of indicators available about the oxygen level, eutrophication indicators, acidification, available directly on the website. So we try to give our best to serve the different countries who want to develop these SDGs and to implement these SDGs.
I can just add to that basically the really important thing, not only about where Copernicus Marine and Copernicus Service is already doing a lot, is and all the researchers from all research institutes around the world, is the data is really important. So first of all, you can know what is happening in the system, and then by having such a huge amount of data, make services or make models that can make predictions of what is going to happen. So without this, we could not really react on time. So this is really helping to be aware what is happening and take actions as soon as possible.
Yes, we are at the beginning of the chain. We are providing core data, core information to allow people to implement their SDGs.
Thank you to both of you. So next question is, is the plastic pollution predicted, and what are the input data of the model? So I think this one was already answered in the chat. But if we want to add something out live.
Yes, for this kind of, so we answered with Tina on the chat, to make this kind of plastic drift computation, you need information about the reverse discharge and a good estimation of the plastic in the different rivers. And then you will use the currents of your sea to estimate the drift and where the plastic will go in the day after. So yes, you need more information than you can find on the Copernicus Marine Service website, but you need currents to be sure that you will be able to forecast the drift of the plastic.
Thank you. So next question was, how many end users and what is the revenue generated by all these services? Following by, in other words, how can these end users can survive without public money? I don't know if Fabrice, you wanted.
Vasily, perhaps.
Or Vasily.
Well, the revenue generated.
This is a tricky question, Vasily. No pressure. No pressure.
Yeah. So, from my experience, is that again, if you find solutions where they save even cents to millions of users, then you can have millions of revenue. So the data is a source of a lot of value. If you pack it correctly and you find innovative revenue that save money to people, they would be willing to pay. The whole trick is to think into smart and I mean, if I dare say, out of the box. There are so many data there. You have to find the right problem. So there's no estimate right now, but you can come with estimates. For instance, if any of you has ever applied for a consulting job, one of the things is to give you to ask you, tricky questions like this: how many boats are in Greece, and you have to come up with the solutions. Like, we have about 10 million people here. Let's say on average 4 persons in every family. So you're talking about 2.5 million, etc. So if you come back to the windsurfing clubs, just try to find how many windsurfers are in the Mediterranean basin, and if you can provide them with a very good service that saves them, I don't know if I gave a very clear question, but the point is, entrepreneurship is not about certain revenues; it's just about the potential. So.
Yeah. I think we can say that it was a valid answer for a tricky question. So if we move on to the next one, thank you, Vasily. It's because we have also we have to take in the time into consideration if we want to address most questions. So is it possible to obtain track particles in Mercator platform, which I think are the viewers of the Copernicus Marine platform? Track particles.
Not now, but we are continuing improving the viewer and the tools accessible for the users, and perhaps in the next update in the next year you will find this kind of tool on the Copernicus Marine Service, because this is a topic very important for us. So we are I would say a team dedicated to this kind of topics at Mercator Ocean International. So we work a lot on this. So yes, perhaps a good surprise in 2023 with the possibility to track particles with a new platform.
Thank you, Fabrice. Next question was, are data taken from each individual cases, or is there a possibility to use data that has been collected for another study? Of course, if the data is known to be of good quality, something like data exchange or data trade.
And we talk about what case?
I think it was about use cases. What I said on the chat is that all the use cases use most of the data is from Copernicus Marine Service. So when you, for example, if you access through the website to the use cases, you can see which variables and products they're using from our catalog. And this is free and open, so you can download all the data sets.
Okay, quickly moving on, and we will take like 2 more questions. So how could you improve the marine service to contribute in the assessment of GES for MFSD?
So basically, when it comes to Marine Strategy Framework Directive, we have already done a lot of things in the past, also collaborating and combining our efforts with EMODnet. We also had some of the user engagement calls when we encouraged users to develop certain applications that would help in a better better application or better help MSFD. And we are continuing with such efforts. And one of the things that we are also trying to develop a bit more, it's this ocean monitoring indicators that Valentina presented, and that are also now included in our product catalog, and we are trying to also to extend them and to develop them a bit more. There is also the Ocean State Report that we didn't mention today. There is also covering a lot of topics that are problematic in MSFD, like eutrophication and losses of biodiversity. So there are many different initiatives, and also there is a recent focus on a more coastal environment where MSFD and other framework directive are going to gain a bit of the highlight. So that it's not like a really like straightforward answer, because we are really trying also to work a lot with the policymakers and being aware of all the actions that are present and how, as a service, we can help out. I hope that this helps a bit in your in your question.
Thank you, Tina. So next question is, how is the demand for NRT data in comparison with MI? Greater or lower? If you have an equivalent.
Yeah, I don't have the numbers here, but I would say that both are highly requested by our users. The thing is that you use both type of data in a very different way. So we have users that they need near real-time data for model assimilation or other things, and others that they need multi-year products. So it depends on the kind of research that you're doing. You're using one or the other one.
Okay, thank you. Maybe last question is about marine acidification issue. Is there where these products such as prediction models could be found in the Copernicus catalog?
So yeah, if you go through the catalog and you use the search bar and you put pH, for example, you will find that you have model products and in situ products that has pH as a variable. So from there, well, you have I don't know, more than 10 or 15 products available for that.
Thank you. And so just the last one this time. Is there an ecological niche model to assess sea species distribution?
I can answer this. Yes, we are at the beginning of the development of biological model. So for species, but already on the catalog of products, you can access to different Nekton products. You can go directly on the viewer and check the different layers. You will find this micronekton products available on the Copernicus Marine Service.
Thank you, and thank you all for your interesting question. We will move on now to the conclusion. So we will just like to say that this entire journey allowed us to have main takeaway from all the three parties that we mentioned at the beginning. So end user, Copernicus Marine Service, and downstream users. So the end user, we hope they get better idea of how to identify and formulate their challenge that they are facing in their everyday life. And hopefully there are now pathways for solution to solve these challenges, and hopefully developers and startups will maybe take on their challenge to answer them. For the Copernicus Marine, we gain interesting feedbacks on needs and requirements for both parties, end users and downstream user. And when we talk about service evolution, it's really important for us to have this feedback, as Fabrice mentioned earlier in his presentation. So this is really important for us. And as downstream users, they gain new idea and better knowledge on the data and Copernicus Marine Service and possible business opportunities. So I think on that side, this innovative event was useful for all these three parties. So now if we think about what will happen in the future, we had possible pathway of ideas. It's launch a survey for having a greater even feedback from the downstream users. Also organize some informal open mic meetups to further discuss needs and just inspiration of how to use the data and what everyone is doing using our data. It's always important for us to know. And also just pursue connecting end users and downstream users together and foster this discussion and collaboration. It's always important to move on this. So as a conclusion, now if you want to follow and where to start, we just want to let you know that we have on the Copernicus Marine Service e-learning material available with Jupyter notebooks, GIS tutorial and tutorial videos. We also organize regular webinars and training events tailored for new users, giving access to relevant data, to demo and training exercise. And to further engage our user and more advanced user, we We host hackathons. We organize some MOOCs and very tailored courses using this data for concrete sustainable projects. So just check our event page and stay tuned because we will announce soon some of the next events. But in the meantime, you can also go to our YouTube channel, and we have a lot of replays of past events available. So please just stay tuned for next event. And that will be the conclusion. So thank you all for attending, and please also check your inbox because you will receive a thank you email that will also include this recording and the slides that you have seen today and all the videos. So yes, thank you very much. And if all the speakers would like to turn on the camera and say goodbye to you all, and thank you very much.
Bye. Thank you.
Thank you. Bye-bye.
Bye.
Bye-bye.